Okay, section 3.4, basically we're doing the same thing we've been doing all week. We're still solving equations, still getting x by itself, except now, instead of just having a problem where we have the variable on one side, we might see an example where the variable is on both sides. Okay, so just as an example, we're not going to solve this. You might start to see problems like this. It's the only difference with the problems you're going to see today. You've got a variable on both sides. Okay? That gives us a few more options when we're solving it of how to solve it. Right? We're going to try to give you guys some steps that make it as easy as possible. Okay? All right, so until now, all the equations we've solved always had the variable on one side. Just like these examples. Variable just on the left, just on the right, just on the right. Okay? Both sides. All right, so we're going to be doing pretty much the same steps, okay, that we did yesterday. Okay, and I think this is where your notes, this is where they start, right here. All right, but there's going to be one extra step after simplify that we got to deal with. All right, so simplify. We're not going to rewrite all the steps under simplify. You already have that on the other side of your notes. But what are the two things that go under simplify? Even though we're not going to put them down again because we already did. Kayla? Distributive property and one other thing. Yep, Sabrina?
Combine like terms.
Yeah, combine like terms. All right, those are the two things that are under simplify. All right, next part. Okay, this is new, so now you've got to start filling in on your notes. We're going to have a letter, okay, with a number, basically on each side. We got to decide. We got to take all these x's and we got to put them on one side, and we can choose. Do we want to take all the x's and move them to the left, or do we want to take all the x's and move them to the right? Well, the way Mr. Roy and I are going to show you how to do it, we're going to try to avoid a negative number. Okay, we're not saying you can avoid the negative forever, but we might be able to avoid it at least for a little bit. Okay? So what we're going to do is move the smaller number. Okay? Move the smaller number. So like in this problem, we'd take 2x, and we're going to move that one because it's smaller. Right? In this one, you can almost think of it, it's like less work. Think of a smaller number, it's lighter. It's easier to move. We're going to move that one to the other side. Right? How do you move it? Well, you got to do the opposite operation. Okay? So if you look at this 2x, is it a positive 2x or a negative 2x? Just look at what comes to the left of it. Yeah, this is a positive 2x. So if you did the opposite of positive would be what, Corey? Negative. Okay, that's what we're going to do. We're going to go just like this. Okay, we're going to subtract 2x from each side. All right, so as you're writing that in, write down next to example 1. I think you've got that right. You've got a spot for it right on the right-hand side. Write down exactly what I'm writing. We had a positive 2x. We're going to subtract 2x, subtract 2x. Okay, what happens when you do 2x take away 2x? About Victor, what happens when you do 2x take away 2x?
Well, positive 2x and a negative 2x.
Does it become positive?
If I give you $2 and I take 2 right back, how much you got?
0.
0.
Does it become just x or no?
Is x the same thing as 0? No, 0. Right? So if you have 2x, take away 2x, you've got nothing there.
That's why we moved it to get rid of it. Guys, why wouldn't it have been a good idea for Mr. Hager to subtract 6 from the x's? Why would that have been? I mean, you could do it, but why would it have been the best way to do it? Anybody have any idea why? Alexis? Exactly. You're going to end up with a negative, right? you're actually gonna end up with a -4. When I do these problems, when I do equations, I don't wanna, unless I really, really have to, I don't wanna deal with negatives. That's why we're telling you guys, move the number that's attached to the variable that's bigger. Or if you have to move a constant, just a regular number, try to move the smaller one. In this case, you wanna pay attention to the sign. If it's a negative, you wanna move it, right? So you don't have to deal with it. That's all. Like I said, when like adding and subtracting positives and negatives, I always say to look for the sign with the bigger number. All right? Do that, but for this, you want to pay attention to that sign. That's really important. You're not dealing with negatives.
Do everyone see what Mr. Wright just said? The whole point, we're trying to avoid the negatives. It's a really good point, if we can. We're not going to say every answer is going to come out positive.
Yeah.
We might not be able to avoid negatives forever, but put it off for a little bit. Okay, so on the right-hand side now, the 2x is gone. Okay, we got -21. How about gauge? What do I get here? 6x, take away 2x.
4x.
4x? Anything else on the left-hand side I got to still put?
Yeah. Yeah, you gotta put on the left side.
Good.
It's bringing everything else down. That's all we're doing.
Yeah.
Now from here, this is exactly what you guys did in last night's homework. You've got 2 steps left to solve this problem. Notice where all the letters are now. They're just on one side. Okay, so after you do this move step, all your letters are going to be on one side. Maybe the left, maybe the right.
And then that next step, right? Then that next step, we talked about that yesterday, right? What's that A stand for?
Addition.
Addition, and then the S stands for?
Subtraction.
Perfect. Yeah, so we'll do addition or subtraction. I'm not going to make you guys write out all the information that comes after that because we haven't made notes yesterday.
So Ben, is there any addition or subtraction you think we need to do here?
Yeah.
Yeah, what is it?
Add 5 to both sides.
Good. Add 5. Add 5. -5 plus 5, that's gone. Left-hand side, how about Ryan? What do I still have left on this side?
4x.
Good. 4x. And now we got -20
The other side's a
plus
little
5.
the other side's a little more tricky.
It's -21 plus 5. Think about you're adding numbers with opposite signs, so we take the sign of the bigger number. Which number is bigger here? Which one, Corey? Negative.
21 is bigger than 5.
So we take the sign of the bigger number. And how much is it? -16. Perfect. Yeah, -16.
So then we have the addition and subtraction step, then we have the second or the last M. Sabrina, what's that last M stand for?
Multiplication.
Multiplication, and the D stands for
Division.
division. How do we know if we're, Jalen, how do we know if we're gonna multiply?
If they're set up like a fraction.
It's a fraction, right? How about Logan? How do we know if we're gonna divide?
If the, say like 6 is next to the x.
Exactly. Whole number with the variable, we're gonna divide. Like Jalen said, if there's a fraction with the variable, then you would flip it and multiply. Okay? Just like what we did, that was what? I think Tuesday night's homework?
Okay, so what are we going to do here? Multiply or divide? Count? Yeah, we're going to divide. What do you divide by? 4. We're going to divide by the number that's next to the x.
Colin, why'd you pick 4? Exactly. Always, I believe me, Mr. Hager and I saw it last year. We had to get to the end of the year that was still multiplying by the number on the other side. Always multiply by the number that's attached to the variable.
Okay, and then our last step, let's just get our sign first. About Jalen, negative divided by a positive equals a negative. And then 16 divided by 4.
Oh, you start
Yeah.
with me? Oh, 30? Is it 30?
Close.
Check it. Is 4 times 3 16?
No.
No. 4 times
4.
4.
There you go.
And we already said it was negative. Okay? So those are the kind of problems we're going to look at today. Just got variables on both sides. Does anyone have any questions on what we just did? Has everyone got that copy down? All right. Do we have one more of those, Mr. Roy?
I
Just
don't believe so.
One more of the basic ones?
No.
Mind if we throw one in just to practice?
Hey, if you want to.
Let's do that.
Tell me.
Right. Let's
I'm gonna do a mistake, I can write down there, right?
just want one of the issues.
Okay.
Let's just do one more because we're going to look at some special cases, but we want to make sure you guys have at least the standard case, which you're going to see this a lot down. All right, special cases, you'll see them a little
I
bit,
just want to show it to you guys.
but you're not going to see special cases a lot. All right, let's try this one. All right, we got 9x minus 5.
Guys, we're just gonna, you don't have to worry about writing this one down, all right? I'm just gonna go over it so you guys can see.
Equals 6x plus 13.
I mean, I see some people do it. If you have some space right below the one we just did, next to the steps, you can fill them in there if you want. We're not requiring you guys to do it. If you want to write it below that, you can, but you don't have to.
All right.
You like that one, Mr. David?
Yeah.
All right, good.
All right. So we're going to go through our steps. Okay. Start with our simplify. Do I have distributive property to deal with here? Alexis? Nope. No distributive property.
Alexis, how do you know? It's no distributive. Yeah, no parentheses.
Do I have like terms that I can combine on the same side as equal sign? Victor?
Yes.
Remember the
I
last?
don't know,
How come, Victor?
because of the equal sign is.
Or opposite side, that equal sign like blocks it. You can't do that.
Yeah. The only time we'd have like terms, Victor, like if I had something like this, now I got some like terms I can combine.
They have to be on the same side.
Okay, so now we go to our new step. What's our new step?
We have to do.
Or what is it? What letter does it at least begin with? How about Sam? The next step after
have to
S?
simplify.
You go from 9 like terms.
We did that, we talked about that.
Oh, you move and
Yeah, we're going to move. So we got a choice. What are we trying to move now?
the negative 9.
Not yet. We're not moving the numbers yet. We're moving the,
What?
we're moving the letters. Okay? So we're going to move them. So we have a choice. We can either we could put all the x's on the left, or we could put them on the right, but let's try to avoid negatives. So how do we know which one to move? Should we move the 9x, or should we move the 6x? Caitlin?
One is less.
Yeah, whichever one is less in this case. Right? Which one is less?
6x.
6x, good. So we're going to move this to the other side. Can someone else tell me how to move it? How do I get that 6x on the other side? Victor?
You divide it, I don't know, multiply it by itself.
Well, what sign is 6x? Look at what's in front of it. What's right here, even though we haven't written it?
Is it
It's positive or negative?
positive?
It's positive. So what's the opposite of at positive 6x?
So it would be negative?
Negative
Yeah.
6x. Okay, so anytime you're moving the number with the variable, it's always add or subtract. Okay, so this new step is always an add or subtract.
Yeah. Like we said in the notes, match it up. Make sure you're gonna subtract that variable on one side, you're gonna subtract from the variable on the other side. You have to match them up. You can't subtract that minus 6x from the minus 5. It doesn't have a variable attached. You have to match them up.
Okay, another way to remember it is anytime you have something with a letter, we're never going to divide with a letter. Ever. Okay, we will never do division. So if you accidentally write down divide, When you divided with a letter, erase it. Don't ever divide with a letter, okay? You can only add and subtract with letters, for now. Okay. All right, so that's gone. Justin, what's 9x take away 6x?
3x.
Good, 3x. Just going to still bring down the -5. And I'm going to bring down the 13. Okay. Now, this is just like a problem from yesterday. Michaela, what's my next step after I move all the letters to one side? Go ahead, look at your notes. What, you're going to what? Yeah, we're going to add or subtract. Good. Do you see anything I can add or subtract here to get x by itself? Add what? Yeah, add 5. And where else do you want to add 5? To the 13. Good. So if you did it on both sides, kept everything nice and balanced. Okay. -5 plus 5. That cancels out. On the left-hand side, Gabe, what do I have on the left now?
3x.
What on the right? Think about 13 plus 5. Well, start with 3 plus 5.
18.
Yeah, 18. Okay. Right, and my last step. What's my last step to get x by itself, Alexis? Good. Divide by the number that's attached to the variable. And as I was hoping we get a nice answer here, 18 divided by 3, Logan, gives me what?
I got 6 over 1.
Yeah, 6 over 1. Or you could just write 6. Both answers are correct. Yep. All right, so we just wanted you guys to see at least 2 of the basic ones, all right? There's 2 special kinds of equations that can come up. Right? It's possible when you're solving these, you actually try to solve it and you get no solution. Has anybody ever done that in algebra? They try to solve an equation, and not that you did something wrong, but it's just an equation that's impossible to solve. Okay, maybe one person? All right, so we'll see what that looks like. And then there's kind of the opposite case, where you go to solve the equation, and any number is a solution. You could plug in anything you want and it would make the equation true. Right? So this is kind of 2 weird cases, and we're going to show you what happens. All right? So no solution, it's impossible to solve, or any number is a solution. These don't happen a lot, very rarely, but they do happen. Okay? If you get the kind of problem where any number is a solution, that's called an identity. Right? And we're going to give you one example of an identity and one example of a no solution. Okay? Has anybody seen that word before? Identity in math? Gabe's seen all this stuff. All right. All right, so let's try. They have this one, story.
I'm just gonna write it out. They have space for it. They're just gonna write it out.
Okay. Okay, so write this down. -17 minus x equals 8x plus 6 minus 9x. Okay, and keeping in mind what I just said, something different is going to happen here. We're just going to start solving it like normal, but all of a sudden you're going to see something happen. Okay? All right. So look at our steps. Okay, hopefully by now we know the first one is simplify. What's the first thing I got to check for under simplify? Alexis? Okay, I agree. Actually, that is what we're going to do here. Is there anything else we want to check before like terms? even if we don't have to do it in this problem? Distributive property. Okay, we're going to get into that, but we don't have to do it yet. Okay, so Alexis said like terms. I agree, there are some like terms here. Anybody tell me where they are or what they are in this problem? Yeah?
8x and 9x.
8x and negative. 8x, take away 9x. So for now, just take the left-hand side. Just copy it down. I'm not doing anything with it yet. Okay, right-hand side, 8x, take away 9x. Yeah. 8 take away 9 is negative 1x, or as Sam said, negative x. Perfect. What else do I still have on the right-hand side besides negative x? I still have the plus 6. Good. So I've got my negative x. I don't need the plus. Negative x and a positive 6. Did anybody write it like this? Same thing. Yeah. It's the same thing. You could do it either way. Doesn't matter. All right. And let's look at the next step. Next step is move. Okay, we got to get all those x's on the same side. Should I move the x that's on the left to the right, or the one that's on the right to the left?
The one that's on the left to the right.
Okay, let's move the one that's on the left over here. How would I do that, Sam?
Add x to both sides.
Okay. Add x. Add x. Let's see what happens. Okay, Ryan, what's negative x plus x?
X? 0.
Yeah, 0. Okay, you've got negative x plus x is 0. So on the left-hand side, all you've got is negative 17. Okay, let's combine our like terms now on the right-hand side. How about Ryan? What's negative x plus x?
0.
This has never happened before. All right. Now on the right-hand side, Victor, what do I have left?
Is it 6? Negative 6?
Is there a negative in front of it? Positive 6.
Something missing, Mr. Hager.
What happened here? Where are my letters?
They canceled out.
They all canceled out.
Yep.
All right? So anytime you get a case where all your letters cancel out,
Variables.
no variable left, one of two things has just happened. You either have no solution, meaning it's impossible to solve, or all real numbers, meaning any number is a solution. Negative 17 equals 6. Is that true? Is negative 17 equal to 6? No. So what do you think this means?
You can't solve it.
You can't solve it. Okay? This is not a true statement at all. Negative 17 does not equal 6. So what we do is write no solution. That means no matter what number you try to pick for this original problem, you will never make the left-hand side equal to the right. It's impossible. You cannot find a number that would make it work. Ever. All right? Can't solve it. All right? So in a way, the no solution, it's actually a little shorter. All the variables cancel out, you're done.
And there's no multiplication and division.
So we stop. Okay, as Mr. Roy just said, anytime all the variables are gone, we're not even going to worry about multiply or divide. There's no variables left to do that with. Okay, so that's a no solution. All right, let's try this one. And then I think we got a word problem, and that's probably the last one.
Yeah.
Okay. That second to last question right here. And then, or maybe a third to last question, but we're almost there.
Mr. Hager's gonna add himself.
All All right, so thinking through your steps that we showed you guys, anybody tell me the first step without any hints from us? What do you think first thing is? Maria?
Simplify.
Okay, good. Simplify. Go for it. What are you thinking?
Distribute, but there are no parentheses.
Good. Distributive, but there's no parentheses, so don't worry about it. Okay? You want to keep going with the simplify steps since you're the simplify master?
And combining like terms.
Good, I like it.
In 2A and 5A.
2a and what?
Negative 5A.
Negative 5a. Okay, we're being picky about those signs, aren't we? 2a and negative 5a. All right, and I'll let you finish that up and then you're off the hook. All right, 2a, negative 5a. What do you get when you combine them?
Negative 3.
Negative 3, what goes with it?
A.
A, good. Okay, Maria did a lot of work there. So let somebody else finish it up. I think it's going to be our last step, actually. Now we're at that move step. Yep, Alexis, do you want to move all the A's to the right? Or do you want to move them all to the left? Okay, we're going to move everything to the left. How would you move negative 3a to the other side?
Please add 3.
Good. Add 3a. Make sure you line it up under the other one that has the letter. And Alexis, what does that come out to? What's negative 3a plus 3a?
0.
0. What about negative 3a plus 3a again? 0 again. Who can tell me what is left here? Caitlin?
4 equals
4
4.
equals 4. Kind of similar to what we had before. All the letters are gone, but it says 4 equals 4. What do you think this means? Yeah, Sam?
Any number.
Yeah, any number is a solution. Okay? So the way we write that, we just write this phrase down. All real numbers. What does real mean? Real means not fake. No. Real means basically positives, negatives, fractions, decimals, anything. Okay? I don't care what number you pick. You can't make this equation false. Anything that you pick will work. 2, 7, 1/2, 3 and a third. Any number you pick will make this work. Okay? And the way you know that happened, all your variables canceled. 4 equals 4. Ask yourself in your head, wait a minute, does 4 equal 4? Yeah, 4 equals 4. All real numbers. Okay? Everyone okay with that special case?
Want a break? Come on, bullpen.
Anyone okay? Everyone's good with that? So how do you know when it's no solution? What happens when you
The variables cancel out.
variables cancel out and the numbers don't equal? Perfect. How do you know that it's all real numbers as a solution? What has to happen there?
Variables cancel out and the numbers equal each other.
Variables cancel out. So in both cases, variables cancel out, but this time the numbers equal each other. All right?
Getting loose.
And calling up out of the bullpen, Mr. Roy.
Do people know, people now look at me around. You guys know what you know what the bullpen is? Yeah, like in baseball, like, that's where the pitcher warms up. That's what I'm talking about.
This is kind of a preview a little bit. We're going to get into this more next time, but you guys are doing so good, we
Yeah.
think you can handle it.
And there might be a couple on your homework that look like this, so we want to give you guys something that you can look at and do. Right?
And this is the second to last problem.
Ryan J. This one right here. What's the first step?
Combine by terms?
Okay, before that, in the simplified part, there's something else.
Distribute.
Nice. So, when I distribute, Ryan, what do I do?
Multiply the number outside the bracket by the number in.
Both inside, very good. So when I do that with this first part here, what would I get?
10.
Okay, 10, anything else?
And 4y.
Okay, what type? Positive or negative?
Negative.
Nice job, right? Nothing here, positive. Sign to the left goes with it, right? So I get a negative 4y. So I had one distributive, all right? Samantha A, am I going to distribute that negative 1?
No,
How come?
because it's not next.
Yeah, it's not next to the parentheses, right? So all I'm going to do is just bring that down, all right? So bring it now what?
Distribute the 3.
When I do that, what do I get? Tell me the signs, two things.
Alright, no.
Huh? What kind? Positive or negative? Awesome. And one more part. Give it to me, Sabrina.
3 times 3.
Which is? Very nice. Good. So all we added here was when we get rid of those parentheses by doing distributive, there still might be a chance that there's, what's the next part after doing the distributive? Guys, what's the next part? After distributive is, Alexis? Not yet. Still in the simplified part. Combine like terms, right? You're going to say that, Ariana? Combine like terms. All right? So, I'm at that part. Look on the left-hand side. Left-hand side, equal sign. Michaela, on this side, over here, are there any like terms? Okay, are these the same 10 and negative 4y? How come? 10 doesn't have a variable, all right? And y has a variable, so that's not going to work. All right, so we can't do anything on that side. So what I'm going to do is just bring that down so I don't forget. All right? Mr. Newman, on this side of the equal sign, are there like terms? And can you tell me what they are and what their signs are? Negative 1 and negative 3. Negative 1, negative 3. Mr. Newman? Yeah, I know, I'm a mean person. I'm making you do math on a Friday morning. What do you get when you do that? What? Negative 4. How come that what? Newman, you got a negative and a negative. Isn't that a positive? How come? He's on it. He may have his head down, but he's on it. All right? Remember, we're combining, right? Keep the sign, add the numbers. That's where I get the 4. Logan, what's left?
The plus 3y.
Plus 3y. Very good. Now, so we did the simplify part. We did the S. The step we added today, Alex. After the S is the what?
Move the small.
Right? So M, right? SMAM. So we're doing SMAM, right? SMAM. All right? So we're going to move. What do you want to move?
The small number.
Which? Small. You want to move the smaller number or the smaller variable?
Number.
You want to move the number first? Can we do that, Mr. Hager? Are you okay with that?
Yeah, we can. I mean, it's not the order we've been following, but
Yeah. I mean, if you want to, you can move the number first. What are your two numbers? Are your two constants, Alex?
10 and negative.
10, negative 4. Which one do you want to move?
Negative 4.
Negative 4. How are you going to do it?
Plus 4.
Add 4 there. And what else are you going to add 4, Alex? This is not division. Sorry, I'm going to add 4 here right to 10. Christmas colors. What do you get?
14.
14. Everything else just comes down. Minus 4y equals 3y. All right? Sam she's woke up. Mr. Roy, I'm back. What do you think?
Add 4y.
add 4y, right? 'Cause now I want to get, there's nothing else. I say, okay, I look at these things and I say, okay, there's one of those things that's not like the two others. 14 is a constant, a number, there's no variable. These guys are the same. So whatever's not like the two other things, all right, this thing, I want to leave them alone, all right? These guys here, they're buddies. They want to be together. This guy here, he's already been moved around enough. He doesn't want to be poked at anymore. All right? So, I got this negative 4y. We know that I'm going to leave the 14 put. We're not going to move that. So, to move that negative 4y, what do I have to do?
Subtract 4y.
It's already negative.
Oh, add 4y.
Awesome. Thank you. So, add 4y. I'm going to add 4y over here. Bring the 14 down, just like that. On the right-hand side, what do I get? 7y. Perfect. Divide both sides by 7, right? Try to wrap that multiplication division part. Everybody sees that? Victor, you back there? Obey, you good? All right. I'm divide by 7. Divide by 7. These cancel out, right? Again, like I've told you guys before, we're not just dividing for the fun of it. We're trying to get that variable by itself. That's the whole goal when you solve an equation. Y equals 2. Y equals 2. Right? So that one, like Mr. Hager said, that's a preview of what's coming up. All right? That's a preview of what's coming. Do you want to do the word problem, Mr. Hager?
You feel up for it, Mr. Roy? You got this.
All right, so everybody's got this down? You want me to get this down? All right. I think I can handle this. I hope so. I'm a little rusty when it comes to these. All right, guys, I'm not going to make you write this down. It's going to take too long. Say thank you. I'm not going to make you write this down. It's going to take too long.
Thank you, Mr. Roy.
Thank you. You're welcome. All right, what do we got? Let's see what it says. Jane has $30 and is saving at a rate of $7 per week. Susan has $50 and is saving at a rate of $3 per week. When will they have the same amount of money? All right. This is intense, Mr. Hager. Might be a little rusty with my word problems, but I'm going to try. All right?
What I would do is start out by coming up with an expression for how quickly Jane is saving money. Then do it for how quickly Susan is saving money. And then worry about the last question, when will they have the same money? Worry about that after. So start with an expression that represents how much money Jane has. Start with that.
What do people think for Jane?
30x plus 7.
Very close. You're on the right idea. Almost exactly what you want. How much?
30x minus 7.
Well, how much money does she have right now?
30.
She has $30. Let's start with that. So write down like Jane. Maybe Jane 30. Plus, how much money is she saving every week?
7.
7. And that happens how often?
Every 7 days.
Every 7 days, every week. She saves $7 more every week. So how would you represent that?
X.
Yeah, you could use X or you could use W, but that's where your variable is, right? So after 7, that's where our variable goes. Right? So now let's say after 1 week, if you plug in 1 for X, what's 1 times 7? 7. Plus how much money she had before, now she has 37. After 2 weeks, what's 7 times 2?
14.
So now she has 14, plus how much money she started with. What's 14 plus 30? 42. Okay? That's your formula for how much money Jane has. 30 plus 7x. All right? Now you've got to do the same thing for Sue.
So it'd be 50 plus 3x.
Right. She starts out with $50, and she saves $3 more every week. Okay? So after 1 week, she's got 3 times 1 is $3 plus 50. What's 50 plus 3? 53. After 2 weeks, what's 3 times 2?
6.
6 plus 50? Now she's got 56. After
So
3
would
weeks, and so on.
Would the equation be 30 plus 7x equals 50 plus 8x?
Yes. All right, so your goal basically
I
now,
was worried because I thought it was gonna be one with, distributive. That's why I was concerned.
this is what you're trying to figure out. When will, was it Jane?
Yeah.
When will Jane equal Sue? Okay? What's our expression for Jane? What did Mr. Wright come up with for the formula?
30 plus 7x. I mean, 50, no. No.
30 plus 7x is Jane, right?
Yeah.
Jane is 30 plus 7x. Okay, somebody else. What's our formula for Sue? Caitlin?
50 plus 3.
50 plus 3x. So does everybody see what's happening here? Sue is starting out with more money, but is she saving a lot of money per week?
No.
Not really. Okay. Jane is starting out with less money, but she's saving money faster. So eventually she's going to catch up because she's saving money faster. Okay? And now from here,
You want to just leave that, just set it up, Mr. Hager, just so we know how to set it up, and do you want to solve it?
why don't we finish it up real quick?
Okay.
All right. I have 2 or 3 steps left to solve this.
I could have done that, Mr. Hager. I thought for sure it was going to have distributive properly. That's what I was worried about.
Add 7x to 3x. I mean, subtract 7x from both sides.
Now, if you subtract 7x from both sides, what kind of number would you get when you do 3 minus 7?
Negative.
You get a negative. So what else could we do to avoid the negative?
Subtract 3x.
Let's do it that way. Okay, so at least if you didn't copy down the whole word problem, at least write down this equation and then the steps on how to solve it. Okay, 7 take away 3 gives me 4x.
And then subtract 30 from both sides.
Yeah, if we put all the x's on the left, we got to put things without x's on.
That one thing that's not like the 2 others, leave that alone, don't move it.
So 4x equals 20. X equals 5.
All right, it gets out. Yes, very good. X does equal 5. And how did we get that? Can somebody tell me how we get x equals 5? My last step.
Divide by 4.
You divide by 4. Okay, so basically after 5 weeks, they will each have the same amount of money. So that's how you solve it. Any questions on that one? A little tricky. Word problems are always a little tricky, but we'll continue to practice them. All right, so the homework for tonight, okay, it's not going to be due till the next time we see you guys, which is on the 14th.
Yeah.
So this is due 9/14.
Monday.
Okay, so that's your assignment to do over your shop week. Okay, and now we're going to try to set up your binders a little bit.